Hi, thank you so much for having me. It's a pleasure. So it's not the first time I've been at this conference, so it's a great pleasure to be here again and to be back. And you did a great job introducing me. That it sounded great. My name is Enrique Soto. An oncologist, and I specialize in geriatric oncology at the National Institute of Medical Science in Mexico City. And today I'm going to talk about the use of patient-generated data to guide decision-making in older adults with cancer. And I think this is a very relevant issue, particularly in developing countries like India and Mexico, because I do believe that we have a great opportunity to use information technology, and particularly the great availability of smartphones and of mobile internet connections to help us better understand our patients, how they are experiencing treatment, and how to provide the best quality of care for them in geriatric oncology. I have no financial conflict of interest disclosed. So the way in which we care for our patients is changing. And this has been accelerated during the COVID-19 pandemic. So before the pandemic and traditionally, the consult has happened in the clinic. So we see the patient face to face, we take notes, we examine the patient in an office environment. But today, and with COVID-19 particularly, we've changed to a more virtual environment, like the one we have today, in which we see our patient through a computer screen or through a smartphone. And although this may have some shortcomings, it also has some promises. So there are strengths related to the use of digital technology and to the use of telemedicine. And some of these are the capability of having more intensive and robust monitoring of our patients. So we are able to potentially detect toxicity earlier and to identify functional decline earlier as well when patients are getting treatment. And we are also able to support or provide an earlier provision of supportive care services. And again, this is an opportunity to foster self-management. So we do have a new channel of communication with our patients that is constantly there and that allows us to allow our patients to have a better self-management strategy than we could have in the clinic when we only see our patients every 2 or 3 weeks. Patient-reported outcomes have shown to improve the outcomes of patients with cancer. So this is a study that was presented by Ethan Bash a couple of years ago. And in this study, conducted at Memorial Sloan Kettering in New York, they used a patient interface for the self-reporting of symptoms. This happened online or through telephone systems. And what they showed was that patients who were able to actually report their own symptoms and tell their physicians about how they were feeling at home had better quality of life, had reduced hospitalizations, and in fact, this led to improved survival. So patients that were actually able to report their symptoms in real time through web-based systems were able to get better care at an earlier stage, and this led to improved quality of life and to improved outcomes. However, this happened in a setting that was very controlled. So these were younger patients, the mean age was 61 years, and this happened at Memorial Sloan Kettering, which is one of the largest and best prepared cancer centers in the world. So of course, the outcomes of this are not necessarily transferable to what we see in low and middle income countries like India, Mexico, Brazil. This is another great example, a study conducted in France of patients with lung cancer that were able to report their symptoms using an online system. And patients that reported their symptoms using the system were able to get treatment at an earlier stage, and this led to improved survival. Again, this happened in a population in cancer centers in France that had mostly a younger age and that was able to access highly specialized care. So again, this is not necessarily something that we can extrapolate to the everyday life of our patients in Mumbai or in Mexico City. So what are the barriers for this type of setting? So what are the barriers for us as physicians practicing in low and middle income countries for implementing this type of studies or this type of strategies with patient-reported outcomes. The first is building a system itself. This is not something that is feasible in most areas of the world. The other is the integration into medical records. So many of these studies had these systems integrated into their electronic medical records. We know that in many settings in developing countries, there's not even an electronic medical record. A lot of people are still doing their things in paper. These studies or these strategies had dedicated full-time personnel that was able to check the website, answer the phone calls, solve patient issues. Most patients had internet access, and most of these patients had an elevated health literacy. So most patients with cancer in Memorial Sloan Kettering have a college degree or higher, and we know that in low and middle income countries, many of our older adults have elementary school or middle school education. So this may not necessarily apply everywhere. So the main question I want to answer today is how can we tackle these barriers for older patients with cancer using innovative technology and patient-generated data without the need of having very complex systems for monitoring? And I think that one of the answers is the use of the Internet of Things. So the Internet of Things is a series of physical objects that are embedded with sensors. These sensors have a processing ability and are able to connect with software in order to provide ubiquitous computing. What this means is that many physical objects like wearables, watches, even clothing can connect and exchange data with other devices in order to monitor some very specific and very important vital parameters for patients, such as pulse, temperature, weight, step count, activity, pulse, and all of these can lead to emergency notifications that physicians can act upon in order to provide better care for patients. What would a framework look like? A couple of years ago, we published a study in JCO Clinical Computing, and there is a framework for using the Internet of Things in order to monitor a patient. One source of information is self-report, so patients can actually go and self-report their symptoms to web portals, as we saw in the studies from Memorial and from France, or through the use of smartphone apps. But the other is the use of Internet of Things. The advantage of Internet of Things is that it doesn't actually require patients to do anything. It only requires them to live their lives as usual, and they are able to generate the data on their own. And this can be obtained through wearables, smart homes, the use of smart scales, or blood pressure monitors, the use of e-textiles, which are clothes that can actually sense body composition or sweat, or smart objects, such as, again, scales, heart rate monitors, etc. This information can be used for a couple of things. One is symptom monitoring, so this can be related to symptoms due to the cancer or to the use of chemotherapy, such as adverse effect assessment, and also through the obtention of physical activity data, which we know is very important to assess the activity as an individual is taking, and the toll both cancer and its treatment are taking on a specific patient. And all of this information can be processed through machine learning and data processing. It is important to understand that all of this information represents hundreds of thousands of data points. So if we are going to use digital technology to obtain information for our patients, we actually need to develop the platform to use this data and to integrate it in a way that can be interpreted. These are literally hundreds of thousands of data that on their own are impossible to understand. After we process this data, how can we use it? So there are a lot of things we can do using this wearable technology and the Internet of Things. We can do posture detection. We can do task completion. We can actually understand how our patients are able to complete tasks that are needed for everyday activities. Sleep monitoring, the monitoring of everyday activities. We can use step counts, which are a proxy of everyday activities. We can analyze gait. We can make an analysis of energy expenditure, and we can actually look at the detection of falls, and see if our patients have fallen in the last hour. And all of this can be integrated and visualized by physicians. So how can it look? So we could actually, in the future, be looking at our patients, hundreds of patients that are getting treatment, and be looking at their posture, their sleep, their gait. And this is something that I believe can actually be done across the world, even in low and middle countries like ours. So what are the advantages and the disadvantages of the use of the Internet of Things? The advantages are that this produces objective patient-generated data that is useful for populations who cannot complete questionnaires. So if our patients can actually self-report their activities, perhaps self-report is the way to go because it's easier. But for patients that cannot do that, the Internet of Things is a potential solution. In contrast, these types of solutions may be expensive or difficult to obtain in some settings. So even today, in countries like India or Mexico, etc., providing patients with smartwatches or with VivoFit devices, etc., may not be cheap enough in order to make this achievable for everyone. So a very important thing for researchers, because I know that many of you are interested in this type of things, is how do we design, plan, and study this type of interventions? So how do we actually take these digital solutions, this Internet of Things, and adapt it to patient-centered studies? And I want to highlight this very interesting paper by Armin Shalautny, which was published in last year's ASCO educational book. And this review, and I encourage you to read it, it highlighted the steps necessary to conduct a study using patient-generated data and patient-generated information using the Internet of Things digital solutions. So the first thing we need to do is to select health concept of interest. What are we going to look at? Are we going to look at function? Are we going to look at pain? Are we going to look at cognition? And after we select that health concept of interest, we need to identify metrics that measure the concept. So if we are going to assess activity, then perhaps we need to measure gait, we need to measure gait speed, steps per day, etc. So we need to select a concept and then to identify metrics that are validated and measure that specific concept. After that, we need to find a suitable device that is clinically valid. So if we're going to measure steps, then perhaps what we need is a smartwatch or a smartphone with a very good accelerometer that is able to measure what we want to measure. The next step is to develop an analytic plan because we're going to obtain 1,000 data points, hundreds of thousands of data points. So we need to develop an analytic plan before we even start the study in order to interpret those data. And finally, we need to utilize appropriate studies. So this is very important, and I think that for all of us researchers working in low and middle income settings, where there are a ton of smartphones, apps, etc., we need to have this in mind before we even start developing our studies. How are we going to select a concept of interest, identify metrics, find a suitable device, develop an analytic plan, and then use appropriate studies? Here I show you some examples of studies using wearables in oncology. This is a study conducted at City of Hope by Virginia Sun and her colleagues. And what they did was a very simple thing. They used wristband pedometers in patients with cancer who had undergone abdominal surgery. And they compared this with what they usually did, which was the use of surveys that were completed electronically. And they saw that the use of this wearable device had a higher adherence than the completion of surveys, and that daily steps were actually associated with surgical complications. So patients who, after undergoing surgery, went home and walked very small distances, had very few steps, were far more likely to have complications than those patients that, after going home, walked longer distances or were more. So this is a great example of the use of digital technology and wearables to understand how our patients are undergoing treatment and experiencing the side effects of treatment. Another great example of the use of digital technology is the CyCore system. So this was presented by Dr. Peterson and colleagues in ASCO and also published in JNCI monograph. This was a study undertaken at MD Anderson. And what they did was to develop a home-based system called CyCore, in which after patients underwent surgery for head and neck cancer, they were home and they had an entire Internet of Things installed at their home. They had an internet-based weight scale, blood pressure monitor, pulse monitor, etc. And so the researchers were actually able to monitor the weight, the body composition, the pulse, the blood pressure of the patient after they went home. And this was coordinated or integrated with patient-reported outcomes. And they conducted a randomized clinical trial in which over 300 patients who had received radiotherapy for head and neck cancer, which I know is highly prevalent in India, were randomized to CyCore monitoring, in which physicians checked the vital signs and the weight, etc., of the patients daily, in contrast with usual care in which patients went to clinic. These were patients that had a median age of 60 years, and the main objective was the self-report symptoms. What they saw was that patients who had an Internet of Things-based monitoring at home had an improvement in general symptoms, so symptoms were detected earlier and acted upon earlier, and this led to an improvement in head and neck symptoms that was long-lasting, even weeks after treatment. So having patients monitored closely at home actually leads to improved outcomes, and I think this is something that's very useful, particularly in settings like ours, where patients are not able to have direct contact with physicians or come to the emergency department as easily as they could potentially have in more developed regions of the world. So regarding the current status of wearables in oncology, this is a very interesting systematic review that was published recently, in which 25 studies were identified, mostly including patients with breast cancer. Most studies using wearables in oncology were pilots for observational data and had mostly feasibility outcomes, and the most commonly used sensors were accelerometers. And what most authors report was adherence. So adherence is very high to accelerometers. If we give a patient an accelerometer or a sensor, it is highly likely that they will use it. So I think the main barrier is not that patients use it or not, but how we interpret this data and how we use it to make everyday clinical decisions. What types of sensors do we have? So we have all types of sensors, going from very simple wristbands, such as these, to more complex devices like the Garmin VivoFit, which is highly used in many studies. Even the same smartphones can be used like a contained device that actually has the accelerometer in it and can also transmit the information. And some studies have used more complex devices like these armbands that can actually measure blood pressure, temperature, etc. So we can go from very simple sensors to very complex ones. So why is this an attractive concept for global oncology, and why is this something that can be very attractive for researchers working in low and middle income countries? Well, this is a way to tackle geographic and cultural barriers. This is something that we can make accessible for patients living in remote rural areas, because we know that in many parts of the world, there are more phones than people. This also solves the fact that in many areas of the world, there is a lack of personnel with geriatric training. There is a lack of telephone triage systems and of web portals. And in many places, toxicities are not detected in a timely manner. And this is particularly relevant for vulnerable older adults. So I think this is something we can all relate with. In many times, we see patients that come to clinic, we give them chemotherapy, they come back 2 or 3 weeks after, and they tell us that they felt terribly bad for 2, 3, 4 days at their home, but they had no one to call, and then they come back to us after they had severe toxicity, and this may lead to decreases in functional status, and this may decrease our ability to continue providing chemotherapy. So the earlier detection of chemotherapy is relevant for many of our patients. So why is mobile technology an innovative solution and an ideal solution in my perspective? because it's an optional communication strategy. This can allow for the remote assessment of toxicity. And there is emerging data from patients in developed countries. So even though people are doing this in the developed world, this is hard to extrapolate to developing countries like ours. So I do think that it's a huge opportunity for us as researchers to develop this strategy. And there are few interventions developed specifically for older adults in low and middle income countries, particularly because there are concerns about technology literacy. So whenever we think of a study that mixes older adults and smartphones, older adults and information technology, there is always this concern about how older adults will be able to use this technology and to be able to adapt it. And why is this important for the developing world? Well, as you can see, most of the world's smartphones are in low and middle income countries. So India, in fact, is one of the largest consumers of smartphones, and many of the top 10 countries in the world using smartphones are low and middle income countries. So India, Brazil, Indonesia, Mexico, we have a ton of smartphones. So this is a huge opportunity and a great platform for interaction with our patients. So how can a smartphone be used to detect, for example, chemotherapy toxicity? So we know that functional decline is a marker of toxicity in older adults with cancer. And we also know that mobility can be measured using the sensors available in commercial and that a ton of our patients have. So what we wanted to do, and I'm going to talk about what the research we've done in Mexico, we wanted to analyze whether functional decline measured using a decrease in the number of steps per day could actually be or represent a novel method for detecting toxicity in older adults getting chemotherapy in a developing country, in this case. So in order to do this, we developed a study in which we included older adults, 65 years and older, who had any solid tumor and were starting chemotherapy in any setting. And what we did is before they started chemotherapy, we collected their socio-demographic data, their tumor and treatment characteristics, and a geriatric assessment. We conducted this geriatric assessment that had all the features that you already know. Before they started chemotherapy, we gave them a smartphone and we recorded the number of steps per day using the Google Fit API, which is something that is freeware and very easy to adapt. At the start of chemotherapy, we gave side effect education as per standard of care, and then we asked the patient to use the monitoring system for 1 cycle. And in any patient that has a declining number of steps of 15% more from their baseline recording, we told them, we assessed their toxicities, and we implemented interventions. At the end of the cycle of chemotherapy, we conducted a new geriatric assessment with obtained patient history. So we assessed 52 patients for eligibility, 40 patients were included in baseline recording, and those 40 patients, all of them completed follow-up. So as you can see, these patients are probably very similar to what we see in India. They had a median age of 72 years. Most of them had advanced disease. 60% had less than high school education, and only a quarter had previous smartphone use. Interestingly, a lot of patients live very far away from a hospital, some over 1,000 kilometers away. Looking at their geriatric assessment, many of them were dependent in their instrumental activities daily living. Many of them had physical impairment. A lot had nutritional impairment, so many had lost weight. 2/3 were living alone or with another older adult. And approximately 1/3 had impaired hearing or impaired eyesight. And despite all of these issues, many of them or most of them were able to actually use the smartphone and send us data using the smartphone. So on average, we recorded 11 days before the start of chemotherapy, and the median number of steps per day for our patients were over 3,000. Here I show you the feasibility. So we looked at the number of days of each chemotherapy cycle in which the patients were actually able to send us their steps. This was conducted automatically. So most of the patients were able to, or most of the subjects we were able to obtain their steps, and most of them considered it very acceptable and very important and feasible for them. Regarding a decreasing number of steps, we found a decrease in the number of steps of 50% of total chemotherapy days. And on those, in 30% of those days, we detected some type of toxicity that was potentially actionable. 60% of the patients had toxicities managed over the phone, 25% were sent for urgent medical care, and 12% of the patients were actually hospitalized after toxicities were detected using the smartphone. So we were actually able to detect toxicity earlier and to act upon it. So what does this show us, and how can we use this in developing countries like ours? So patient-generated data that can be obtained with smartphones or other Internet of Things devices can provide additional information that obtained from patient-reported outcomes. Sensors can measure almost anything and generate a great amount of data. And I know that countries like India are highly developed in the use of sensors or of digital technology. This can be a potentially useful solution to extend the reach of geriatric oncology in resource limited settings. And a very important thing is knowing what sensors to use, what to measure, and how to interpret the enormous amount of data generated. And I want to leave you with this quote from Admiral Grace Hopper, which is from the US Navy. The most damaging phrase in our language is "we've always done it this way." So we actually need to change the way in which we assess and act upon the deficits we find in our patients. And we need to find a way to harness technology, simple technology such as smartphones, to provide better care for our patients. And I think it's something that is highly feasible in countries like ours. So thank you very much. And I'm happy to answer any questions.
Thank you very much, Dr. Enrique. That was really, I should say that you have, you've shown us, kind of given us a goal and also a crystal ball, all mixed into one. So thank you. That was really very nice. So are there any questions, please? I'm sure there are many. I'm sure there are ideas buzzing.
Thanks, Dr. Soto. That was really, really thought-provoking. Excellent. So, couple of questions for you. One is in the use of smartphones. So I know most people have a smartphone. My mother has a smartphone. The issue is that she doesn't keep it with her, by and large. So whenever I try to call her, I need to get through on the landline and then say, pick up your cell. So in terms of using it to count the steps, did you face any issues with that?
Oh, I think this is all an issue of communication, no? So one thing that we found, or one thing that is very evident was, and I'm sure this happens to you in India, is that many of our patients feel alone. So they come to clinic, and at the time they're in clinic, they're with us, but then they go home, and when they're home, they do not have a system that supports them. So in developed countries, they have telephone hotlines, they can call a nurse, they can contact their physician, even through web-based portals. But in low and middle income countries like ours, if patients have side effects, they have to go to the emergency room, and this in some cases entails traveling long distance. So if you actually show patients or you educate patients that their smartphone can be a direct connection to their physician, they won't leave it behind. No? And this actually becomes a very important tool. And what we've seen is that patients actually feel that the smartphone connects them to their healthcare team, and that this is a companionship to their care. So I think that this is all a matter of communication. If they see the smartphone as their connection to their doctor, to their healthcare team, this is something that they will keep with them. And we actually showed that over 90% of our patients were able to send us their steps every day. We are now conducting a longer study, which we're following patients over 3 months. And so far, our experience has been great. So patients actually use this, and they feel that this is something that is taking care of them. So I think this solves this problem of our system being too limited to have continuous support for patients. I don't know if I have answered your question.
Yes. I think at least it's a roadmap, at least for us moving forward. Another question before I hand it over to the organizer. So, any data privacy issues? So, if you're accessing Google and you're accessing the phone and the step count and other things, are there any data privacy issues involved?
Yeah, so there can be. So so far we've done this under a protocol, so patients actually sign an informed consent. But what we do is we inactivate the GPS tracking system. So I always say patients, I know how much you walk, but I don't know where you go. Because so I don't want to know where patients are going. So the order to do that is you inactivate the GPS and you don't know where they're going and you only track their number of steps. So in that way, there are ways to keep the patient's privacy and just detecting their physical activity.
So interestingly, the lockdown has actually led to more telecommunication and a certain comfort level on both sides. So we've actually done teleconsults of patients who've completed radiation and inspected their skin reactions over the phone. But I think what was interesting was how you proposed that we integrate this with using prompts via phones. And that I think is really, I think, as Dr. Vanita said, very thought-provoking and definitely something that we'll all be contemplating.
No, I agree. I mean, we've done a lot of telemedicine as well, and I think this is a great opportunity. We've used a freeware platform, so most of my telemedicine clinic takes place over WhatsApp video calls, and so most patients have that. If they don't have it, a younger relative has a smartphone with WhatsApp, and so this is a way to provide care to patients who in many cases are thousands of kilometers away, and we can see their hands, have them weigh themselves. So this is I think it's a great opportunity to extend the reach of our services, and this is something that has been accelerated by COVID. So if this was not acceptable before, now with COVID, it's more acceptable. People say, well, this is something I want because I don't want to go to Mumbai or Mexico City, etc., where there's a lot of COVID.
True. Thank you very much, Dr. Enrique. I think for reasons of time, we'll move on. And please do continue the discussion in the chat box and later on the panel discussion.
Ma'am, a single comment. May I go?
Sure.
Yes, sir. Really, in the last 2 years, what we have witnessed too, that most of our patients are on WhatsApp, and now the patients are too very much comfortable on WhatsApp call. So there are two aspects, that is the subjective one and the objective one. What we see is the patients have got their complaints, they can show us the scans. And what about their objective, that regarding your pulse, blood pressure, we depends on ask them to get hold of a local practitioner or a local nurse and then get back to us with the vitals. But this aspect of using the smartwatches and other things, in India still the smartwatches are of Apple and other companies which are still too costly for a normal Indian being. Might be the Chinese version may start now promoting those so that we may get access to the blood pressure and pulse of these patients too. But do you think that generating so much data and so intensive monitoring, we should have a cutoff where we are going to intervene? When the patient complains, it means that they are changing the vitals and now they are complaining and then we are advising them. But just by the vitals monitoring and we are changing any treatment?
Yeah, so these are great questions. So I think that the first thing I want to tell you is 5 years ago, I told you, we're going to give smartphones to everyone. You would say, come on, that's crazy. It's too expensive. And now we can get very cheap smartphones. So I think that wearable devices are going to get cheaper. And in a year or two, even today, we can get very cheap wearables. So smartwatches are going to get very cheap. Everyone is going to have a smartwatch eventually. So we have to start planning for that. So regarding the data, we need more research about how to actually use those data in everyday clinical practice. So if patients are walking less, if patients are doing less physical activity, what the hell does that mean? And that's what we need to do. We need to work on that to see if that actually can lead to treatment changes. And we don't have that data yet. So I love having that data because I see that my patients are not walking enough. And usually the patients that are not walking enough are feeling worse. And I usually tend to focus more on those patients because I know that they need more care. But we need to actually produce the data to show others that these type of measurements are valuable. And I am sure they are, but I think this is something that we need to do, and that also researchers working in some countries have a huge opportunity to do this, because we are in a great position to use this type of easily available technology to improve the care of our patients, and we don't have the pressure of having to compete with other systems that are already established, like phone lines, etc. So this is a great opportunity. And for example, you guys that you see a ton of patients with head and neck cancer and things like that have a lot of toxicity from treatment, you have to start studying this, because I think you're in a great position to do it.